students. In last class, we discussed about the steps involved in gravimetric analysis. The steps involved in gravimetric analysis, there are 8 steps or 8 techniques are involved in the gravimetric analysis. In that, first one is precipitation method is completed. Second one is co-precipitation. Third one is a post-precipitation. And the fourth step is a digestion of azine. Up to the post-precipitation is completed in last class. In today's class, I am going to discuss about the digestion of azine. The azine is very important for 4 marks question in your examination. Only again technique. Digestion of precipitate. Next, the digestion of precipitate. The unit name is gravimetric analysis. Gravimetric analysis. In gravimetric analysis, the digestion of precipitate. The digestion of precipitate. Okay, digestion of precipitate. You already know the post precipitation, co-precipitation, and what is meant by precipitation. When it is completely formed without the co-precipitation, without the impurities are present in our precipitate, this is after the digestion of precipitate, or also it is again the name is another the digestion or azine or again. This is digestion of precipitate, or again these two are same meaning here. It gives the same meaning but the terms are different here. The digestion of precipitate. In this process, the digestion of precipitate process, the precipitate is also used to stand here. It is used to stand contact with its mother liquor. Here it is used to contact with mother liquor for a length of usually 2 hours to 24 hours. 2 hours to 24 hours. Is used with the contact with mother liquor, that is usually is used the 2 hours to 24 hours. The digestion is the length of timing for digestion process used the 2 hours to the 24 hours or 1 day. It is here the 24 hours, it is 1 day. Either at room temperature or at here or at temperature depending on the nature of the precipitate. Here this digest at room temperature or depending upon the nature of the precipitate. The temperature is depending upon the nature of the precipitate, and here the digestion is not done. When the digestion is not done, the precipitate is gelatinous, or if there is a possibility of post precipitation. When the digestion process, the digestion step is not done. Here, the possibility of formation of post-precipitate or co-precipitation. Here, the possibility that is a gelatinous precipitate is formation. The possibility is gelatinous precipitate is formed. Gelatinous PPT is formed. On the presence of, it shows the presence of the post precipitation, and during this time is slowly large particles of precipitate is generated. Here the slow time is slow and the large particles on the particles of the precipitate is formed or generated, which can be easily filtered. Here this digestion is time is taken, the time is longer time. Here the digestion process is a longer time. It takes a longer time, that is the longer time is 2 hours to 24 hours. It digests, it is contact with mother liquor or used for a sand bath. Here this sand bath, you take a sand. Here this is a iron plate and you take a here sand. You kept your beaker on this sand and heat slowly, heat after you take digest. Here when the large particles are formed, then it is formation of large particles of precipitate is generated or obtained in your mother's or a beaker. Here then it easily filtered. When formation of precipitate, afterwards when the gelatinous precipitate is not formed, when no co-precipitation, post-precipitation is formed, and the process is easy. When it is the presence of impurities, it comes the weight, the substance or compound weight in our original weight here. And this after the digestion is easily or after again it easily filtered. This is a digestion of precipitate or algae. After digestion, the filtration and washing. After digestion, the filtration and washing. Next step, the filtration and washing. Filtration and washings. Here the precipitate is separated or from mother liquor is decanted. Here the filtration means is separate. The solution and precipitate is separated. From the mother liquor is decanted. Mother liquor is presence of solution and precipitate, and mother liquor is decanted through an ashless filter paper. In gravimetric analysis, you use the ashless filter paper, that is a Wattman filter paper number 40 and 41. Here for gravimetric analysis, the quantitative using the quantitative filter paper. The quantitative filter paper, that is a Wattman filter paper number 40 and 41. You use these two filter papers. These are the Wattman filter papers are quantitative filter papers. In any of the you are using any of you are doing any of the gravimetric experiment, use these quantitative filter papers. Here the ashless filter, because of this is a ashless filter paper, there 40 and 41, and without disturbing the precipitate. Without disturb the precipitate, I use the for filtering purpose. Use these filter papers without disturbing the precipitate, and then the precipitate is washed. After the filtration is completed, after you wash the precipitate thoroughly with washing liquid. Use any of the washing liquid or hot water to remove all the adhering impurities, or you remove the impurities. After this filtration is completed, afterwards use the washing liquid by remove the adhering particles or adhering impurities. And any of the impurities is present, when you wash any washing, you use any of the washing liquid, you remove this impurity, any of the impurities present in our original precipitate. And finally, the precipitate is completely transferred onto the filter paper. Here, finally, it transferred your precipitate on filter paper number 40 and 41. This is another step, that is filtration and washings. Next step, the drying and ignition. Drying and ignition. Drying and ignition. After filtration and washings are completed, then the drying and ignition. Here the precipitate after the filtration is heated to a constant heat. Here it comes when it dry. First it dry, you take on a air hole, use air hole, they dry the up warm the when your precipitate is dried, afterwards ignition. When your precipitate is ignited, dried, afterwards you keep your precipitate with filter paper on in a crucible. Then the crucible is kept in kept in a electric burner, and ignition is taken. Ignition means it heated with a red hot, and here it heating at a high temperature. It becomes high, it is forms of particles, is a residues are formed of here. After drying and ignition, heating to a constant weight. You ignite up to constant weight is up. Here the constant until the constant weight. Heating is takes place until the constant weight is formed or the constant weight is obtained. Heating removes the solvent type volatile impurities. When you heat it in high temperature, the solvent and impurities are removed. Heated at high temperature or ignition takes place, it removes solvent and impurity. Any of the impurities present in your precipitate, it removes. When heating takes place, it removes the solvent and impurities. In some case, the heating is done to convert the precipitate to stable product. When here the heating is completed or here the ignition is completed, and it is your precipitate, the formed precipitate is converted to the stable product of the known composition. Converted the stable product of the known composition. After the ignition is completed, it conversion takes place. Here the conversion is your precipitate is converted to the product, the stable product of the known composition. This is called as ignition. After completion of drying and ignition, finally you weigh your precipitate. Final step, weighing. And weighing. Here, the filtration and washings are completed. Afterwards, the drying and ignition are completed. Afterwards, the finally your product, the known composition product is formed. The weight, when the weight of the residue is taken. Finally, you get the weight of the residue. Before taking the weight, the residue should cool to room temperature. Here, you are taking weight. Before taking of weight, you cool your residue at a room temperature. Cool residue at in room temperature or by handling. Warm temperature by handling here. The residue should cool to room temperature and in desiccator use for cooling. Ignition is completed. It have a high temperature. The residue is heated at a high temperature. You cool at a room temperature. Afterwards, you keep in desiccator. Keep in desiccator. Keep in desiccator and when the temperature reaches to normal. This keep in desiccator and temperature reaches at normal. When temperature reaches at normal, the residue is weighed and it is reported. After the residue is weighed, afterwards you report the your residue weight. After and it is reported. These are the steps involved in the gravimetric analysis. This is the last step for weighing. Before weighing, your residue cooled at room temperature, that is you kept in desiccator. Desiccator, it absorbs the heated moisture and it cools your residue at room temperature. When temperature reaches at normal, the normal temperature is reaches your residue, and after the residue is weighed and it is finally you report the weight of the residue. Okay, these are the steps of gravimetric analysis. The first step is a precipitation method, second step is a co-precipitation, third one is a post-precipitation, fourth one is digestion, fifth one is filtration of precipitate, sixth one is washings of precipitate, seventh one is ignition of the precipitate, eighth is a weighing of the precipitate. Next, the importance of filter paper. Here, the types of filter papers are present. The Wattman filter paper, you know the Wattman filter paper number 40, 41, 30 and 54. The Watman filter paper number is 31 is 31, 30, 32, 54, 52, 50, 41, 40, 42, and 541, 540, and 542. These are Watman filter papers are present used in gravimetric analysis. The before going to the filter paper to study the Watman filter paper, here we are going to study the Watman filter paper. We should know how important in the gravimetric analysis. The filter paper is how gravimetric analysis. The filter paper is how important in the gravimetric analysis. Before studying the filter paper, that is a Watman filter paper. Here, the most important of quantitative filter papers must have a very small ash content. Here, the very small ash content, very small are ashless content here, and the cis achieved by during the manufacture of washing. Then the filter paper is washed with, that is the hydrochloric acid or hydrofluoric acid, HCl or HF. Used in the manufacture of the filter paper, the quantitative filter paper, that very small ash content is present in the Watman filter paper, or it is a quantitative filter paper. The washing soap is hydrochloric acid and hydrochloride here, and another acid is hydrochloric acid. The heading is importance of filter paper. Importance of filter paper. Importance of filter paper. Generally, the size of filter papers used are circles. The filter papers is like this circle here. This type of circle. The circle, the diameter is the 7 centimeter, 9 centimeter, 11 centimeter, and 12.5 centimeter. Commonly using the only 7 centimeter, 7.0, 9.0, 11.0, and 12.5 centimeter filter papers are used in the gravimetric analysis. Here, the diameter is 7 centimeter, 9 centimeter, 11, and 12.5 centimeter. Among all these sizes, size that is 9 and the commonly used in gravimetric analysis, only the 9 and 11 centimeter filter papers are used in gravimetric. Commonly for all the size, only the size 9.0 and 11.0 centimeter diameter papers are most important, are widely used in the quantitative analysis. Here, these two are most important, is widely used in the quantitative analysis. Quantitative analysis means this gravimetric analysis here. The ash of 11 centimeter and 9 centimeter circle should not exceed, that is the ashless, the weight is 0.001 gram. Here the 0.001 gram ash is present. This does not come into your residue because of you are using the quantitative filter Watman filter paper. This is the ashless content when 9 centimeter, 11 centimeter. The ash is present 0.001 gram. And here, if the ash exceeds the value, here it should be distracted from the weight of the ignited residue because of you are using the 9 and 11 centimeter quantitative filter paper. And basically the structure of the filter paper, the texture of the filter paper plays an important role here. structure of the texture of the filter paper plays an important role during the filtration. In filtration texture, you are doing the filtration in experiment. This is important role for using these filter papers in filtration. The texture of filter paper retains the smallest particles of the precipitate. When presence of smaller particles or largest particles and this permit rapid filtration, there are three texture filters. The three texture of filter papers here. Three types texture of filter papers. Filter papers. First one, very fine, that is a first one for very fine, precipitates, very fine precipitates, that is small sized particles. Small sized particles. Second one, for average precipitates, for average precipitate, medium sized particles, and third one, for gelatinous precipitate, for gelatinous precipitate, large sized particles. Here, first, the three texture of filter papers. First one is for very fine precipitate, small. That is the size is very small. The very small precipitate, the small size particles are present. And for average precipitate is present. The medium sized particles are present. And for gelatinous precipitate, the large sized particles are present. These are the three types of texture of filter papers. And the speed of the different texture filter paper. Here, the speed of the different texture of filter paper. I written F of the filter paper here. The speed of the different texture of filter paper here. First one is a small size particle, slow, that is a low texture paper. When the speed is slow, that is low texture paper. When it is medium, that is a medium texture paper. Medium or is average here. Medium texture paper or used. That is speed of the different texture of filter paper. First, large texture of paper. Okay, here the different types of texture, three types of textures, and speed is also three different speeds are present in the different texture of filter papers. One When the slow speed, low texture paper are used, and medium texture paper are used, and another the fast, the speed is fast, the large texture paper is used in the filtration or for using for filtration purposes. Here the presence of the filter papers are hard filter paper. These are the prepared by treating with the nitric acid. Here the hard filter paper, hard filter papers, and these hard filter papers are prepared by treating with the nitric acid. These are extremely small acid contain greater mechanical strength here. The greater mechanical strength is present here, and when wet time resistance to alkalis and acids here using these chemicals for the preparation of hard filter papers. And the Whitman filter paper are predominantly used in gravimetric analysis. Here, the Whitman, because the Whitman, the scientist Whitman is discovered or designed this filter paper because the name is Whitman filter paper, and the Whitman filter papers are predominantly used in gravimetric analysis. The characteristics of are divergent varieties of Whitman filter paper are suitable for only quantitative work. Here, I write the different types of filter paper. That is the Waldman filter paper, the single and single acid worker and double acid worker. These are the divided in different types of filter papers. Right? The properties of Waldman filter paper. Properties of Waldman filter paper. Or types of Waldman filter paper. The column, first column, filter paper, filter paper, second column, fast speed and retain, coarse particle, third column, medium speed, medium sized particle, medium sized particle, medium sized particle, and fourth column, slow speed, slow speed, fine particles, fine particles. Okay, first one, single acid. Single acid, HCl. Single acid, HCl. Single acid wash, HCl. And here ash as present here 9 centimeter, and this is the 11 centimeter. Here the number is 31, and here number is 30, and here the watermelon filter paper number is 32. Watermelon filter paper number is 32. Here the ash 9 centimeter, ash is present 0.00014 gram, and here 0.00021 gram, and here 0.41015 gram, and 0.00022, and here 0.00015 gram, and 0.00023 gram. And second one, second type, single acid wash, single acid wash harden, single acid wash harden, ash here the ash is 9 centimeter and 11 centimeter. The ash is present. The filter paper number is 54. Here the ash is present 0.00014 gram, and here the 1 centimeter 0.00022 gram, and here the number is 52. Weight is 0.00015 gram and 0.00023 gram, and here the number is 50, and weight is 0.00015 gram, 0.00023 gram. And next, third one, double acid wash, HCl HF, ash 9 centimeter and 11 centimeter, and here number 41. Here ash is 0.41057 gram and 0.408 gram. Here the number is 40. Ash is 0.460 gram, and here 0.409 gram, and here the number 40. Here 0.4063 gram, and 0.409 gram. And last one, fourth one, double acid is same here, wash harden, double acid wash harden, HCl HF 9 centimeter and 11 centimeter, ash 9 centimeter and 11 centimeter. Here the number is number 541, weight is 0.41041 gram and 0.4106 gram. And here number 540, weight is 0.41044 gram and 0.41006 gram. And here number 542, weight is 0.41050 gram and here 0.41007 gram. Okay, in this table you are the filter papers. The filter paper number 30, 31, 32. This one 30, 30, 31, 32 and 50, 52 and 54. Very cheap and may be used for elementary students. You are using only the rate is only, it is very cheap and used in elementary students. Here the Whatman, the filter paper number 30, 31, 32, 50, 52 and 54. And the filter paper series 40, 41, 42. This is filter paper 40, 41, 42. These filter papers and another 540, 541 and 542 are totally used in quantitative work. These are used in quantitative work. These are elementary work used in elementary student. These 6 filter papers and these 6 filter papers are used in quantitative. And the number 40 and 42 are preferably used, and the ordered variety number 540 and 542 which have a greater mechanical strength and a greater resistance to acids and alkalis are used in quantitative work, and the precipitate filtration has the number is 41 and the 541 are used for gelatinous precipitate. The filter paper number 41, this one, and another 541. These two filter papers are used in a gelatinous precipitation and then quantitative analysis. The number 40 and 540. This the number filter paper number the 40 and 540 are used for medium sized precipitate. Here these two are used as medium sized precipitate and these two are used in gelatinous precipitation. And the number 42 and 542 are used only very slow filtering. Here this one, the 42 and 542. These two filter papers used in very slow filtering, and for this reason they do not find wide application in protein quantitative and in a quantitative analysis. Here the number of diameters for in microns are, that is the Whatman filter paper diameter is written in microns. Micron is the Whatman filter paper. Right here Whatman filter paper, Whatman filter paper, diameter that is microns. It is written in microns. Remove the 1, 30, second, 31, third, 32, fourth, 40, fifth, 41, sixth, 42, seventh, 540, eighth, 541, and ninth, 540. 540. Here the diameter in micron, that is 2.2, and 4.7 and 1.1, 2.4 and 41. Here 41, that is 4.1 and 42, 1.1 and 540, 1.6 and 4.8. Here the 0.5. These are the diameters written in microns. In your examination, this is a very important question, 5 marks question. Explain or write a note on Whatman filter paper. This is a 5 marks question. Write the types of Whatman filter paper. The types of Whatman filter paper, here 4 types. 2 is a single washed, 1 is a single washed acid, and another is a double washed acid. And in single acid used HCl, and double washed acid used 9 centimeter HCl and HF. Here the single acid HCl ash is 9. Here the ash is present in 9 centimeter and 11 centimeter. In 9 centimeter, in number 31, the Whatman filter paper number 31, the ash is present in 9 centimeter. The ash present weight is 0.00014 gram, and in 11 centimeter 0.00021 gram. In number 30, the ash present in 9 centimeter filter paper 0.00015 gram, and in 11 centimeter 0.00022 gram. Here in number 32, here the 0.00015 gram, and in 11 centimeter 0.00023 gram weight is present. That is, the weight is present. The ash is present in our precipitate. Here this weight is not common in our precipitate because of the it is in 0. The value is 0. It is 0 means it is nothing here. The single acid was the number 55. Here ash is present in filter paper number 54. Here this is 54. What is filter paper number? Here 9 centimeter and 11 centimeter. In 9 centimeter 0.00014 gram and 0.00022 gram, and in 52 the weight is ash weight is 0.00015 gram in 9 centimeter diameter and 0.00023 gram in 11 centimeter. Here number 50 0.00015 gram and 0.00023 gram. And here the double washed acid HC used HCl and HF, that is hydrochloric acid and hydrofluoric acid. The ash present in 9 centimeter and 11 centimeter diameter Whatman filter paper. And here in 9 centimeter 0.00057 gram, and in 11 centimeter 0.00008 gram, and filter paper number 40 0.00060 gram and 0.00009 gram. In filter paper number 42, the ash weight present the 0.00060 gram and 0.00009 gram. And finally, fourth type, the double washed hornel, HCl and HFR used, ash is present, that is 9 centimeter and 1 centimeter. In 9 centimeter, water filter paper number 541. The weight is present, that is 0.00041 gram, and in 11 centimeter 0.00006 gram is present, and in number 540 the 9 centimeter the ash weight is present 0.00044 gram and 0.00006 gram. And here the water filter paper 542 0.00050 gram in 11 centimeter 0.0007 gram, and this diameter in here use 9 centimeter 11 centimeter. Here in microns the diameter is written in the microns. Here water filter paper number 30 31 32 40 41 42 and 540 541 542. Here microns this is 530 2.2 31 4.7 32 1.1 and 40 2.4 41 4.1 42, that is 1.1, and 540 1.6 541 4.8 and 542 0.5. These are the Wattmann filter papers. Okay, I will stop here class. I will continue in next class.